I'm CK. Tonight we've got a module from a company who I have not built a module from before in the past, Winterbloom, out of Atlanta, Georgia in the United States. This is their Helium. It is a multi and precision adder. Everybody needs lots of multis in their rack to be able to spread the joy of CV and LFOs and other things all around the rack. So we'll see how this goes together and how it works, and I hope you enjoy the video. Here's the box. It's a little big for a multi-box, for a module box, particularly a relatively narrow one like this multi looks to be. So we'll see how they've padded it up on the inside. Helium, the part number, $79 US MSRP. Probably a build guide behind that URL, behind that QR code. And as usual, or as often is the case, I picked this up from thonk.co.uk. So it went from the US to the UK and back to the US. Aww. It's a little gift box. It says Helium on it in handwriting. Here's the front panel and the board, I bet. Oh yes, I am living in synth. So we got another sticker for the wall. And nothing else in the box. We'll get it ready for recycling. And look at that pretty box. That's nice. That's what made the packaging as big as it is. Let's open this up. Since it's in an anti-stat bag, I have a funny feeling there's a bunch of surface mount already installed, and yes, there is. Okay. We've got, what are these? I don't know this part number. They're TI parts. I'll look up the part number in the break in a little bit, even though I often say that and don't actually do it. I will try and remember to do it. Helium version 2, October 5th, 2021. Helium winter.dev. This is a pink board, and it's got a trans rights statement on it, which is great. Open hardware, so you can probably find this schematic and board layout somewhere online. On the front, we've got what you pretty much would expect on a multi. Got, let's see, in, out, in, out, in, out, in, out, 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 in, out. That's kind of, let's see what it looks like this way. So all the outs, well, I was about to say all the outs are highlighted in gold, but this out is not highlighted in gold. This out is not highlighted in gold. This out, so I don't know what their coloring convention is. As you can also see here, there are surface mount LEDs already installed. The board looks pretty good, all through hole plated. And again, the front of the module doesn't show a lot. There's little transparency, a diamond, a triangle, a diamond, hexagon or pentagon, and a hexagon. So I guess these are probably grouped. I'm going to make an assumption that they're grouped in fours. But we'll see. So that's the board. And there's something else in the board. I'm sorry. I missed whatever this is. It is a little piece of paper. Oh, it looks like oscilloscope output traces. Tested. So they tested this part. They tested the board itself, the chips, the surface mount chips, and this was tested on Jan 15, 2023. So offset error is 0.17 millivolts, 0.08 millivolts, and the unity mixer standard deviation is 0.2 multi-2 from input, which is not bad. So that'll be nice. It looks like it's a pretty accurate multi-2, which of course is what you want. That's why we buy active multis and not simply passive multis. I'm going to cut the ribbon, and it's not in fact ribbon, it's painter's tape, but we'll pretend it was ribbon. And obviously, since all the surface mount is on the board, this is not going to be much stuff. It's rubber bands. I'm not sure what we're going to do with rubber bands. And I got a bunch of rubber bands anyway. Power cable, another, yes, I am living in synth. That's good. And yeah, this is simply, oh gosh, all we're going to be doing is putting jacks on the board and the power connector. So this is going to go together in a flash. You know, it's one of those things that I could pull up the build guide, and I probably will, but I probably don't need to if all I'm going to do is put jacks on the board. So we'll get the soldering iron heated up. I will go ahead and probably look up that part number, and we'll put this thing together. Well, I had no luck finding this part. I'm going to make a pretty safe assumption that it's some type of multiple op amp. And my confusion here, and it's simply because I'm an idiot, these are ins. They're 1, 2, 3 ins, and each one has 3 outs. So this goes to these, this goes to these, this goes to these, and if you don't plug anything into this and this, and just have something plugged into this, you'd be getting it in all 9 outs, which is very handy. I also looked at their website, and they are a 2-person woman-owned company, which is great. They do all the work they do is in the open source, which is neither great nor not great. It's their choice, and I certainly celebrate that. More importantly, they have pictures of their company cat on their website, and that is a major plus. So what we're going to do is simply just slap this thing together, and it's not, as I say, it's not going to take very long to do this because there's only jacks to put on, and it looks like the only interesting thing is these jacks share ground pins. Not a big deal, just something to be aware of, because you don't want to be searching around for a ground pin that doesn't exist. So but again, I'm not seeing the symmetry unless I'm holding it upside down. And I was holding it upside down. Interesting, the power connector goes on the top? Well, that's iconoclastic, isn't it? But that makes the in 1, 2, 3, in 1, 2, 3. Had I been holding it in the right direction, it would have been obvious to me at that point, but I wasn't. I should have put, as I'm doing this right now, I should have put the power connector on first. So what I'm going to do is I'm going to stop in the middle here and do the power connector with these, because the jacks, because they share ground pins, they tend to stay in better than boards where they don't. The only challenge I see here is the red stripe or the negative rail is only listed by a little minus sign above that column of pins, and that's covered when you have the power connector in. Yes, the power connector is keyed, but keying is one of those things. Keys can lie and get in your way. Why can I not ever get my red marker out without pulling out the purple and the brown and everything else. So what I'm going to do, just to make sure I never screw this up, I'm sorry, to reduce the chance that I screw this up, is I'm going to put a red mark on the edge of the PCB so I know what side the red stripe goes on. Now I'll put this on again. And I will double check with the power connector to make sure the key is set up right to get the red stripe where it needs to be, and it is. So I will just solder these power header pins on. Now I'll put the rest of the jacks on. And you may have seen, unless I cut it out for time purposes, I had to use my solder remover to get rid of some solder between two pins here, because while this board, PCB board color, is a fun color, it doesn't seem to have as good solder resistive properties as, say, a green board, the green material. But we'll see when I do the rest of the jacks if that becomes a problem. That pin's a little bent. And the owl on my roof is making a lot of noise tonight. I don't know if you can hear him, probably not. These mics suppress outside noise really well, but he is distracting me by being so noisy. Okay, what I'm going to do at this point is I'm going to solder one pin on this jack down here. And one pin on this jack up on this corner. Oh, and I'm sorry, this side of the board, which is the side you're actually going to look at when you plug power in, says red stripe. So it's not just a simple minus sign. So now I've got those two pins locked down by a little solder. So I'm going to put the board on. I think that's the way it's going to go. I believe it is. And I'm going to take two panel nuts and put them on oops, I'm going to try and put them on. The two jacks that I soldered one leg down on. And one thing you might notice here, and I'll show it a little bit more in a second, is they're not using the rounder knurled panel nuts. They're using hexagonal ones, and it kind of covers up a little bit of the gold indicating the inputs, but that's okay. Now, with those two held down by their nuts, nothing is moving, and we can solder all the jack points. And the only thing that you need to be cautious of is, since there are already surface mount components mounted on the board, you want to make sure you don't brush them with your soldering iron or otherwise disrupt them. I'm double checking all my solder points because, again, this board is okay about taking solder. It's not great about taking solder. You may want to look at another board manufacturing partner. So I'm just touching up a couple of these. Okay. Now I'll put all the panel nuts on, and actually I was going to turn the cameras off, but I'll just speed this up since this video is going to be so short. And that's all the panel nuts. So the only thing interesting left to do is put the power cable in. And there we have it. Oh, by the way, I didn't mention this because I don't use adders very much, but this will be the adder section with the out there. So that's it. That's the front, the side, the back, the other side, the top, and the bottom. Now we'll put it in the rack and multiply some signals. We're in the rack. We'll turn it on. You'll probably see some activity because I've already got it plugged into my LFO. Make sure the volume is down. Okay. So as you can see, we've got a little bit of activity going here. I've got the LFO going kind of slowly over on the side. And you can see the LEDs changing colors as the LFO goes positive, negative, and so on. So for your viewing pleasure, I've got the LFO input going through my parasite cable, so there's nothing. The signal here is the same as the signal on the scope. Let me bring the scope up. The top yellow line is the original signal. The magenta bottom line is the multiplied symbol, for lack of a better signal, for lack of a better term. So I'm feeding this into frequency modulation. So obviously it is working. Let me look at this, these scope traces, because that's really what, So as I look at this, the magenta line seems to be lagging a perceptible amount. Let me see if I can. Probably had a little bit of a jump cut there because I wanted to take out my bits of fiddling. So you see the magenta appears to be lagging a little bit. Let me speed up the LFO. Yeah, now it's pretty noticeable. You'll see the low on the yellow signal is slightly ahead of the low on the magenta signal. Let me change to another waveform. I'll go to sine wave, and it's still visible. The yellow is peaking a little bit before the magenta. Let me go to square wave. I think it's a little bit. Yeah, it is definitely a little bit ahead. I'm going to go back to the triangle wave and use a different cell. Oh, by the way, as you can see, as I mentioned, the inputs here, and since there are no other inputs plugged, it's being mirrored across all 9. Now when I drop in here, obviously the top 4 are not still working. Let me plug something else into the top multi so it makes more sense. I'll plug the gate from my sequencer in there. So you can see this is pulsing at a different rate than this now. But back to what we're actually looking at. Looking again now, even on this second one, the lower one, it is definitely lagging noticeably. But it's a good unit. Let's see, what else? Let me try something else. I'll put a note CV value in there. and then get another cable to change. I have a cable plugged in already there. I'll plug it in there. There we go. So it is definitely doing its thing appropriately. Yep. So it is definitely tracking the note CV value. Seems pretty accurate there. But again, you could see under the more, in my opinion, critical area like a gate signal and even the sine or triangle wave coming from the LFO, it's not quite as dead-on fidelity-wise as some I've seen, but this is a good unit. It's definitely worth the money. If you haven't built any eurorack modules, this would be a great one to start with because, as you saw, it's so very straightforward and it will give you a sense of accomplishment. Okay, I haven't done one of these before, now I'm going to do it, and there it is. What I didn't do, I didn't test the adder because I don't use adders much. Let me see what we got here. So I can't get that to go in. Okay, so that's in, and I'm gonna try and figure out what I'm plugged into here now. Okay, and this goes to, I'll put this in CV. Trying to figure out what I'm doing here. Oh, not actually plugged in. Golly. So that's CV out from my sequencer. Now I'll add in the gate, and I don't know if I'm going to be able to see anything. Oh yeah. So that's the addition of the note value CV plus a on-off a gate signal. So that's interesting. You can see the magenta line is the one that's got the pulses intermixed. If I take note CV out and instead use sine wave, because again right now all we're seeing is the pulse, and now if I put the sine wave on top of it, or triangle wave, now you can see it's a pulsed triangle wave. So the adder can be very useful for interesting effects and other creative uses of math, and you've got 3 inputs to that. So again, this is a good module. I can recommend it, and very straightforward build. And I hope you enjoyed the video.